Hey everyone, welcome to 197 Concepts. In this video, I'm going to tell you how to use timer and generate a delay of 27 milliseconds. So you will be familiar with timer. So in 8051, there are sorry, it's 51. So there is a concept, there is a software module called as timer. This timer can also be used as a counter. So timer provides time delay, whereas counter counts the time. Okay, so timer just generates a time delay, whereas counter counts that particular time period. Why you need the timer? It's just for synchronization of 8051 with other devices, not the internal components. For internal component synchronization, we are already having the crystal oscillator. Okay, so now what is the main purpose of timer? It is just used for synchronizing with the external components of that are attached to 8051. And one more thing, when you take the clock pulses to generate a time delay, so from the definition you might be clear that timer and counter both are the similar functions, because in order to generate a time delay it must count the time period, like 1 second, 2 second, 3 second and all. And in the same counter function also, it's the same thing. You are going to count the seconds. So the difference comes where you get the source of timer and counter. For timer, you take a section of crystal oscillator frequency and you generate the delay. Whereas for counter, you are going to get the triggering signals outside of 8051. That's the difference between timer and a counter. That's the only difference. Other than that, their initialization, their working, their functionality, everything is similar. So if we use a timer to generate a delay of say 25 milliseconds, it's like generating a clock period of 25 millisecond for for counter purpose. So there's not a big difference. It's the difference just at source from where we are going to get the clock pulses for timer and for counter. That's the only difference. Other than that, it's both are the same. Now, to know the working of timer, you should know what is tmod. Search for the tmod, you will easily know. So there are actually 8 bits, okay, 4 bits for timer 1, let's say T1, and 4 bits for timer 0. And one more thing, I'm going to talk only about the timers, because whatever you get in the timers are similar to the are carry forward for the counters also. So timers can be initiated in 4 different modes. That's mode 0, mode 1, mode 2, mode 3. So mode 0 is nothing but your 13-bit timer, and mode 1 is a regular 16-bit timer. Mode 2 is 8-bit auto reload, auto reload, and mode 3 is just 8-bit, but it's a split mode. So you can easily search what are the modes of the timer and you will get easy description there. No need to get confused here. It's a very simple concept. Search it on the internet. You will get the difference between the different modes. So now when we come to our question, which is here, program to generate a delay of 25 milliseconds using timer 0 in mode 1. So he's asking us to generate a 25 millisecond using timer delay, and that too in a 16-bit mode. Okay, so before jumping into the program, you have to know some basics. So for that basics, I'm going to show. So you should know some basic formulae. So I'm going to talk about those formulae here. Okay. So the very first formula that you should be familiar when you're working with the timers is that the timer frequency, which is nothing but your crystal oscillator frequency divided by 12. And now, what is this 12? This 12 defines the machine cycle. Now, you may ask me, what is machine cycle? So, machine cycle is the time taken by the 8051, as you're talking about 8051 here. In general way, any electronic device that needs some time to complete one fetch cycle, one read cycle, and one write cycle. That means if you take the example of 8051, it needs some time to fetch the next command from the memory that is stored in the memory and to decode it, to read that particular command, and to write the output of that particular command. So the time taken for these three cycles, the fetch cycle, the decode cycle, the read cycle, fetch and decode comes under one cycle. So the fetch cycle, read cycle, and write cycle. That time duration is called as machine cycle. Why we have selected 12? Because there are going to be 12 pulses that are required by the 8051 to complete one complete cycle. That means the fetching of the code, reading of the code, and writing the output for that particular thing. Okay, that's why we have selected f oscillator divided by 12. Then the next formula is timer tick period. So this is nothing but when at what particular time our timer is going to update. For example, it is counting 00. After what duration it is going to count, it is going to be updated as 01. Then next, after some period, it is going to be updated at 02. So that period is nothing but your timing tick period. So how you can find it? See, it's just the opposite of timer frequency. That means 12, same machine cycle. It's related to machine cycle. So 12 divided by F oscillator. Okay. Then next, after this, the main formula that you have to know is the count. Okay. So count is nothing but uh, the number of steps that you have to go from the maximum value backwards from the maximum value. So why is that required? I will tell you later in the next formula. So count equals to required required time delay divided by timer tick period. That means this one. Okay. So count is equals to required time delay divided by timer tick period. This will give us some value. So that, let us say x. Okay. Now finally the preload preload value, which is equals to maximum value minus count. Now, you might ask me why we are subtracting this count from the maximum value. So always remember, the timer is going to be up count itself. It's not going to down count. That means the difference between up count and down count. So if you are going in a reverse manner, like 10, 9, 8, 7, 6, and so on up to 0, then this is the down count. But timers always goes in the up count manner. That means 0, 1, 2, 3, 4, and so on up to the maximum value. This maximum value depends upon the mode. The maximum value of the timer is dependent on its mode. For example, if we take the mode 0, so in this mode we are going to have 13 bits. So this gives 2 power 13, which gives a value of, let's calculate it, 2 multiplied by 13 times. Now, so let's shift this to what is it, scientific? Yeah, 2 power 13. So 2 power y, that means 2 power 13, which equals 8192. So in mode 0, the maximum value is 8192. So that means the timer is going to count from 0 to 8191. Okay. Whereas if you go for mode 1, that is 16-bit mode, in this case, so 2 power 16 will give you a value of 65,536. So the counting will be from 0 to 65,535. And if you talk about mode 2 and mode 3, since it is a 8-bit mode, so 2 power 8, which will be what's 2 power 8? I'm not sure. I believe 256. So let's check once. So clear, and 2 power 8. I believe it's 256. Yeah. So for mode 2 and 3, the maximum count is 256. That means the timer or the counter will count from 0 to 255. Okay. Now, based on this, let us do our process. Let us do our calculations. Um, let us do the calculations. So we need timer 1 in mode 0. So this will be initialized by using the tmod register. This is not related to us, or it's related in the programming side. What we have to do is, here we have to find out what preload value we should load into the timer, so that we are going to get a 25 millisecond of delay. So let's calculate by okay. So 8051 generally runs on the frequency of 11.0592 megahertz. Okay, so this is the general or by default frequency that the 8051 is running. But for simpler purposes, for simpler calculation, I'm going to round up this to 12 megahertz. Okay, so for up to timers itself, I'm going to assume that 8051 is going to run in 12 megahertz frequency. Now, the very first thing that we have to do is we have to find out the timer frequency. So I'm going to write in shortcut form. So timer frequency formula is F oscillator divided by 12. So now F oscillator, the crystal oscillator frequency, I'm assuming it as 12 megahertz divided by 12. So which will give me a value of 1 megahertz. So this will be equal to 1 into 10 to the power of 6. Okay, keep that in mind. And then the next I have to find is timer tick period, which is nothing but 12 divided by F oscillator. Again, that's equals to 12 divided by 12 megahertz, and this will give me 1 microseconds. Okay, so at the bottom, I'm having 10 to the power of 6. When this goes up, that will be 10 to the power of minus 6. So that gives me 1 microsecond. Now, the main thing, count. Count. The formula for the count is required time delay divided by timer tick period. Okay, so what is the time delay that I need? I need a 25 milliseconds of time delay. So 25 milli means 10 to the power of minus 3 divided by timer tick period is 1 microsecond. So 10 to the power of minus 6, which this will give me 25 into 10 to the power of minus 3 plus 6. So this is 25 into 10 to the power of 3, right? So that means 25,000. That's it. So that's the count. And finally, the preload value. The preload value is maximum value minus count. So this is, since it is mode 1, the maximum values, the mode 1 means it's the timer is going to work in 16-bit mode. So the maximum value is 65,536 minus 25,000. So this is equals to, so 65,000 minus 5,000 will give you 60,000, and then minus 20 from there, that will give you a value of 40,000. Okay, so 40,000 536. That's the value you have to load. Now, when you go for the next page, So 40,536 value. This should be loaded in timer 1 or timer 0, whichever I'm using. Now 40,506 as itself, this one itself cannot be loaded into the timers 0 and 1 because this is a decimal value, whereas these can understand only the hexadecimal value. So that's why this 4536 has to be converted into hexadecimal. Now, for that, what you have to do is, so you have to write all the bits. So actually, there's a conversion method, but for easier understanding, what you have to do is you have to write all the 16 bits. So like zero, not zero, starting from 1, 2, 4, 8, that's 4. Then next 16, 32, 64. Then next 64 plus 64 is 128 and all up to 16 bits. Okay. Then you will get some specific value for up to 16 bits. Okay, so do this. It's a very good thing. And if you do this, you will get a better understanding. For time being, I'm just going to convert by using the online converter. Okay, so I'm going to Chrome. I'm going to just type here uh, decimal to hexadecimal. Okay, I'm just going to select this one. And when you observe here, I'm going to type 40,536 value to convert. So that's 9E58. Okay. So this 40,536 can be written as 9E58. Now this is having 4 bits. These 4 bits will be loaded separately. 2 bits will go in lower timer and 2 bits will go in the higher timer of anyone, whatever I'm using, the timer 0 or the timer 1. In the question, it is asking timer 0. So for timer 0 as well as timer 1, we are having higher timer 0 and timer 1, we are having higher bit and then the lower bits. So for that, these are TH0 or TH1 or TL0 and TL0. Oh, sorry, TL1. Let me just undo that. TL1. Okay. Since she's asking us to use only timer 0, so I'm going to load the lower bits of timer 0 with 58 and the higher bits of timer 0 with the value 9e. That's what you're going to see in the program. This is the main thing. Okay, this is the very main thing. And now when you come to the program, is it, let me open the notepad. This will be much easier. And I'm going to shift to this. Let me change the color, right? So see the values here. I'm going to load TH0 with 09EH and TL0 with 058H. So that's nothing but 9E58H. That's the hexadecimal value for 40,536. Okay, you can do the math. So just like I have told you now, 1, 2, 8. Sorry, I missed the number. Let's undo. No, this one. Yeah, this undo. 4, 8. That's 4. 16, 32, 64, 128. Okay. So these four are one set. These four are one set. Then next, what's the double of 128? So I have to calculate it. 16. 120 plus 120 is 240, 236, 240, 256. Okay, 256. Then next 512. Then next 1024. Then next it's 2048. So up to here, how many bits have completed? 4 plus 4 plus 4. Okay, 3 sets are completed. So that's up to 12 bits. Now how many bits I have? I have still four bits. Okay, so that will be like 2048 will give you 16, and that 4489 and 13196. Okay, so the double of 3196. Let us use calculator. Okay, this is not possible. So yeah, in my phone I can use it, right? Where's the calculator? Yeah, 2048 plus 2048 will give 4090. Not 3196. I will get 4090 plus 4090 will give me 8180. Then 8180 will give me 16,360, and then next plus 16,360 will give me 32,720. Okay, now if you add all these 16, this 4 set, this 4 set, this 4 set, and this 4 set will be equal to 65,536. Okay, so now I need 40,536, means definitely 32 is going to come. That's one. Let me change the color. I will take blue. Okay, so 32,720 is going to come. Then next, so now 32,720 plus 16,360 will give me 4980. So this will be 0. Okay, so I don't need 16,000. I will be using 8180. Let me see, that's 40,900. So this is also not necessary. I am going to put this 0. Then next, 4090. 4090 will give me 36,810. So definitely that's within 40,500, 536. I'm going to put that as logic 1. Then next, plus 2048, that's 38,858, and that's under 40,536. That's why I'm going to keep this as 1. Then next, plus 1024, that's 39,892. So definitely that's 1. Yeah, strike off this value, this is not there. Okay, plus 512 will give me 40,394. That's within 40,536. So this is going to be 1 plus 256. So that's 40,650. So I'm going to avoid this. I'm going to avoid this value, and that's why I'm going to put it 0. Now, plus 128 will give me 40,522, which is less than 40,536. So that's why it's 1 plus 64. It's 586. That's way out of our value. So this is going to be 0 plus 32. It's 540, 554, 40,554. Again, that's exceeding our value. So that's why I'm going to put this 0. If I do 16, that's 538. Even this is also exceeding. So that's why I'm going to put this also 0. And finally, plus 8 will give me 40,530. Definitely I need this. Okay. Then plus 4 plus 2. So 110. Okay. Now how do you convert this? This is 8421, 8421, 8421, 8421. So this one will give you 4 plus 2, 12 plus 2, 12 plus 2 is 14. For 14, that's hexadecimal value is going to, you are going to get some hexadecimal value, like say 9A, B, C, D, right? So, so definitely we are going to get a separate value. We are going to get a wrong value. I'm writing something else. So for 14, let us say you're going to get F is for 15. So you're going to get E. Okay. So 9E58. So 9E58. The last digit should be 8, but I'm getting 8. And E, I'm getting 8 here, and then 8421, 8 plus 4 plus 2. 8 4 plus 4, 8 plus 4 plus 2 is again E, and then this one is 9 plus 1, 8 plus 1, 9. Only this digit is correct. All these, oh yeah, this one is also correct. So these two are wrong. So I might have missed the calculation here, but this is the procedure that you have to do. Okay, so that was my main target. Now we know that we are going to use 9E58 value for loading the timer with 40,536. Yeah, I need to clear this all. Now coming to the program. Now I'm starting the program. I'm saying the processor of 8051 to make all the memory towards zero. Then by using tmod register, I'm going to initialize timer zero into mode one. So just search for tmod and you will know what are the bits. Then next, this P1, so P1 tells the port 1 of 8051. I'm going to initiate it with the value of 00. Now this is the loop. This has to be go on. This has to be repeated multiple times. Now, in order to, so P1 when it is set to 0, so P1 is equals to 0 means the graph will be coming. So logic 1, logic 0. So graph is going to be coming in the straight way. But I need some variations in order to calculate the time duration. So what I'm going to do is I'm going to shift from logic 0 to logic 1. Then after some duration, again it should go back to logic 0. And some duration later, it should go to logic 1 and then. So this way I'm going to create a clock pulse. And the difference between these two should be exactly what I need. That means what I need the delay. That means the 25 milliseconds. That should be the difference between these two pulses. Okay, so that is my target. So for that, what I'm going to do is I'm going to take the value of P1, move the value of P1 into accumulator, and I'm going to complement the accumulator. You cannot directly complement the port, so that's why I'm going to move this value from into the accumulator register, and then I'm going to complement this. Again, this complemented value is going to be shifted into the port 1. So initially it was 0, now it is complemented, so it will be generated a value of 1. This value will be passed to port 1. For that reason, I'm going to get a clock pulse in the higher value. And then finally, I'm going to call a 25 millisecond timer delay subroutine, and then I'm going to say that short jump towards this loop. So this is an unconditional loop. There is no condition. Uh, this is a continuous loop. When you go for the subroutine, so you know that we need a value of 9E58H for 40,536. Okay. Why you are going to load this value into the timer? Because from here onwards, from here onwards, up to 65,536, up to 65,536, the total count or the time taken by the timer 0 to come from 40,536 to 65,536 will be equal to 25 milliseconds. That's the main reason why we have to load this value. And this is the main reason. And since the timers will only up count instead of down counting, we have to subtract the count value as I said before. So I have loaded in the higher value, in the higher 8 bits of timer 0, I'm going to load 9E, and in the lower 8 bits of timer 0, I'm going to load it with 58. Then set BTR0 tells the arithmetic and logical unit of the 8051 to start the timer. That's it. Now, in order to repeat this, in order to make this as a loop, what I'm going to do is I'm going to make a subroutine called wait. And here I'm going to tell that you have to jump towards this label until my trap flag of timer 0, which is denoted by TF0, is not 0. That's JNB. Jump when bit is not set. Oh, sorry, I said it wrong. So trap flag when it's 0. So jump when bit is not set. This tells that If my TF0 is not set, that means if it is at logic 0, the loop is going to, oh, yeah, now I get the point. So jump when not bit is not set. That means when the TF0 is at logic 0, you have to make the jump. Okay, where is that jump? That's at wait label. When this TF0 equals to 1, when this trap flag, okay, of timer 0 becomes 1, bypass this line. There is no need to jump back to this label. You can just go towards the next line. And the next line is clearing the TR0. Since we are setting here TR0, now we are resetting it. So TR0, after execution of this line, the TR0 will be 1. When your count is complete, that is when the timer comes to 65,536, the TR0 must go back to its original state, that is 0, or else the timer will keep on counting. So 65,536. Why we need to reset this? Because in 16 bits, so the maximum value is 250 to 65,536. After this value, for 65,537, there are no bits, there are no bits to keep the record, because we need 17 bits onwards. But what, how many bits we are having? We are having only 16 bits. There are no 17 bits. That's why we have to clear the TR0. So that's the clearing the timer 0, and then we have to clear the, so trap flag. You can call this as a so TF0. You can call it as TF0, or by default in the textbook or in the official language, it is called as overflow flag for a timer. So for timer 1, that is TF1. Okay. So this is the overflow flag. And then we are going to tell the program to return to a call delay. Okay. So from there, again, it's going to execute this line, which again tells us to go back to loop. That means now if you are having port 1 equals to 1, then this will be complemented. This will move to accumulator, and it will be complemented to logic 0. Then it will go for the delay subroutine. It will load these values. Then it's going to wait. This is going to execute this segment, and then again it's going to come at the edge loop. So it's a continuous process. So that's a complete program. Now, if you want to check the output, if you want to check the output, I have already typed the program here. Okay, so just you know the procedure how you should do for the Keel software. Now, if you don't know, I will keep the link for uh, showing how to execute a new program in the Keel process, in the Keel software. So since I have already typed the program, I'm directly going to debug it. So debug, start a stop debug session. Okay, click on OK. You will get like this. So by default, you will not get a logic analyzer. You will just get output like this. Okay, now in order to see the graphs, you have to click on the analyze window, which will give you a logic analyzer. Okay, so let me dock it here, or else let me take it out, because it will be much better in this format. Now I need to run this software. I need to run, not software, I need to run this program. Simply, I'm going to go here, that's run, or you can use the shortcut function key F5 from the keyboard. Now you're going to run it. So that's my program running, and then I'm going to stop it. Now, at any section, take select it, press shift, and if you move the cursor, then it's going to stick on towards this value, so towards this rising and falling edge. Okay, so for this pulse is easily visible. I'm going to shift it, and then I'm going to click it. So that's, there's a marker there. Then I'm again going to press the shift key, and I'm going next to the, I'm moving next, I'm going towards the next immediate falling edge. If you observe there, what I'm going to get here at the bottom of the screen, I'm getting a value of 5.62902 seconds. And after that, D, That's the difference. D 24.982 milliseconds. Okay, so in the program we are asking the processor to sorry 8051 to generate a 25 millisecond, but we are getting 24.982 milliseconds. So that's not a big problem. That will be rounded like 25 milliseconds. So from this, by seeing at the bottom screen or by seeing at the what we say, I cannot move my cursor here. It will just shift. It will just move. So by seeing at the display values, what we can say that we have successfully generated a difference of 25 milliseconds between the rising and falling edge, and that's a complete 25 millisecond delay generated by the timer 1, sorry, timer 0 using the mode 1 method. So mode 1 of timer 0. And that's the final thing. So that's it. That's the output. You have to check it, and then when you stop it, you can just restart it. You can just close it, and then stopping this debug session. So that's it in this video, and I hope you have understood how to generate a timer delay of 25 milliseconds using timer 0 in mode 1. Thank you.